Hello students, question number 59. Now the question number 59 is stating that phosphoric acid ionizes in three steps. Their ionization constant have given that Ka1, Ka2, Ka3 respectively. So their overall ionization constant they given as K. Which of the following statement will be the correct they're asking. So here what is the key concept involved here is key concept involved in this question. So here amphiprotic ion, amphiprotic ion, amphiprotic ion is nothing but amphiprotic ion, the ion which acts as, or you can say here the substance, the substance can act as acid as well as base, acid as well as base is called as amphiprotic ion, amphiprotic ion. Okay. Now here the compound has given that H3 H3PO4. Let us go to the next screen so that will be understandable. So here the compound given H3PO4. So here H3PO4 having three H plus ions are present, right? H3PO4. Let us say here. So let us giving this one three H plus ions. Right. Now first what happened? First one H plus remove here. If I remove one H plus no, so H2 PO4 minus will come. Right. Again from this, remove one more H positive. So you will get the here H PO4 2 minus. Again from this, remove another H plus. It become PO4 3 minus will come. Now the question will come that here a removal of one H positive. Removal of one H positive. Look at here. See here. This is the acid. This is the acid. Now it is what happened of its conjugate base. Acid of its conjugate base for this one. After removal of one H positive. That means what happened here? Ka1 will be the ionization constant for this one. Now what happened? Next, H2PO4 minus, now it become its acid now. If I take this as a acid, now if I'm taking this as acid, what about this one? It will be your conjugate base of this one. Here, Ka2 will be the ionization constant 2. Now again I'm taking this will be the acid. The next one becomes what happened? It becomes conjugate base Cb. Now here Ka3 will be the ionization constant. Now, so in this case, what happened? If I want to get the dissociation constant of this particular acid, which one? Dissociation constant of. So if I want to get the dissociation constant this particular acid, so what I get here? So Ka, I can say here dissociation constant of H2PO4 minus dissociation constant, that is Ka is equal to what we have. So Ka1 plus Ka3 by 3 by 2 average. This will be the dissociation constant of H2PO4 minus. Why? So here for this acid, for this conjugate base, this is acid. For this acid, it becomes conjugate base. For this case, you got it right. Now, if I want to get the pKa for H2PO4 minus, if I'll get here, so pKa1 plus pKa3 by 2. This is the value you'll get it, right? Now, dissociation constant of first one is maximum. Dissociation constant, let us say here, Ka1 is more then Ka2, then Ka3. Why this will be happening? Because K1 will be maximum we are removing the H plus a neutral compound. We are removing H plus from neutral compound. We need to give more amount of energy. So that is the reason Ka1 is more, then Ka2, then Ka3. So first point, what happened? So if I want to get the dissociation constant of the center axis, like the center of this one for this compound, I'll have to get the, so before one, after one, we have to add together, we'll get the center compound Ka value get it. If I want to get the pKa in terms of pKa, what is the formula? So pKa is equal to minus log of Ka will come. That is the formula for this case. Okay. Now what happened here? In this case, so we have the first condition. What we have? First condition, second condition, then what we have, so two conditions we have in this case. Another condition, amphiprotic we have seen, amphiprotic, amphiprotic compound, right? Now come to the question, what they're asking. Now, so here, first case what happened? Statement will be correct. So how it came? Now, this third point we'll try to discuss here. What is the third point? So now let us make it as a up to here equation 1 and up to here equation 2, up to here equation 3. If I add three of them, so what happened? Here the condition. What is the condition? When two or more equilibrium reactions, equilibrium reactions added, their equilibrium constants multiplied, multiplied. Now here what happened now? So here we'll see the top in this case. So overall constant is equal to Ka1 plus Ka2, sorry, into Ka2, Ka1 into Ka2 into Ka3. Now apply the log for this one. What happened? Log Ka is equal to log Ka1 plus log Ka2 plus log Ka3, right? If I apply the negative sign on this, if I apply the negative sign, so what I'll get here? Minus of log. So here minus log Ka minus log Ka1 minus of minus plus I'm keeping as it is minus log Ka2 plus minus log Ka3. So this become, so Pk is equal to Pka1 plus Pka2 plus Pka3. This is what will get it. Now go to the option. See statement 1 absolutely right. Statement 2. H3PO is stronger acid than H2PO4, and why? Because this is pure acid. It is amphiprotic ion. Amphiprotic ion means it is not that much of strong. And whereas this one is 2, it is more amphiprotic ion. So the statement 1 is absolutely right. Now, dissociation constant, first one is more than second one, then third one. Why? H positive we are removing from the neutral compound. We need to give the more amount of dissociation energy. That's why it is a K1 is more. Now, fourth one becomes wrong. Why? It has to be like this. Ka2 is equal to Ka1 plus Ka3 by 2. That can be the right. But fourth option is completely wrong. So we have A, B, C is the correct answer. Thank you.